Hello there, and welcome to this lesson on Further Pure Mathematics 1. We're on Chapter 1, which is an introduction to complex numbers. And we're on 1.1, and this is the third of 3 videos on 1.1. In this video, we're going to return to quadratic equations and how quadratic equations and complex numbers connect together. Equations of the form ax squared plus bx plus c equals 0 are quadratic equations, and they all have 2 solutions, or roots. Roots is the word that's more commonly used, certainly in A-level maths. If you see the word root, it means exactly the same thing as the word solution. The first possibility is the discriminant of the quadratic, b squared minus 4ac, is greater than 0. If that's the case, then the equation has 2 distinct real roots. That means it's got 2 solutions, 2 roots. They are different from each other. That's what the distinct means. And they are both real numbers, normal numbers. So for example, x squared plus 5x plus 6 equals 0. B squared minus 4ac would be 5 squared, which is b, take away 4 times 1 times by the 6, which gives us 25 take away 24, which is 1. Now, the only significant thing about the 1 is that it's positive. It's greater than 0. That means that the equation will have 2 roots, 2 solutions, and they will be different from each other. Now, if we go back to the equation, it's an equation that's easy to factorize, x plus 2 times x plus 3, which means it's easy to solve. X plus 2 times x plus c equals 0 has got 2 real solutions. The first one, x equals minus 2, if that bracket is equal to 0, and the second one, x equals minus 3, if the second bracket was equal to 0. The second possibility is that b squared minus 4ac actually equals 0, exactly 0. So for instance, if you had x squared plus 6x plus 9 equals 0, b squared minus 4ac would be equal to 6 squared, take away 4 times the 1 times the 9, which is 36, take away 36, which is exactly 0. Now in that case, if we were to factorize the quadratic, it'll factorize into 2 brackets with exactly the same thing in each bracket. In this case, x plus 3 times x plus 3, which multiplied together would give us that. And solving the equation, there are still 2 real roots. So x equals minus 3 from that bracket, and x equals minus 3 again from that bracket. 2 roots, but they are the same as each other. The normal thing to say would be that the equation has got repeated roots. But it's the third case that we're interested in, where the b squared minus 4ac is negative, where it's less than 0. Now, for an example, we'll just look at an extremely simple quadratic equation, x squared plus 9 equals 0, where b is equal to 0 because there is no x term. So b squared minus 4ac would equal 0, take away 4 times 1 times 9, which is minus 36. Again, the significant thing there is that it's negative. Now, if it's negative, we will still get 2 solutions, but just going back to the equation can easily be simplified in this case because there is no x term. X squared equals minus 9, and from the first lesson, we now know that the square root of minus 9 does have a solution. It's just that the solution isn't a real number, it's an imaginary number. So x could equal 3i, or it could equal minus 3i. But there are 2 solutions, distinct, they're different from each other, but both of them are complex. And we'd say that the equation has got 2 complex roots. Now, because b squared minus 4ac is so important, it has a special name. It's a name you may well have heard before, and I mentioned it earlier on. B squared minus 4ac is called the discriminant of the equation. You should also note that there is a convention, and it's a pretty strong convention, this, when dealing with variables which can be complex numbers, it is much more normal to use the letter z rather than the letter x. So for instance, this equation you wouldn't see written down as x squared plus 9 equals 0. You would almost certainly see it as written as z squared plus 9 equals 0. And the 2 solutions would be z equals 3i and z equals minus 3i. Now, obviously, it doesn't matter what letter you use. You can use any letter you choose from any alphabet. The useful thing about following the convention and understanding the convention is you immediately get a hint. The moment you see the letter Z, complex numbers should go into your head. the possibility, the almost certainty that you'll be dealing with complex numbers and that the solutions will be complex numbers. Okay, there's 3 examples for you to have a go at yourselves. And I've suggested the method that you should use to do them. Obviously, you can use whatever method you choose. But when I go through them, the first one I'll just be doing using common sense. The second one I'll be doing like we did those last ones, using the quadratic formula. I know we didn't use the quadratic formula, did we? But I'll use the quadratic formula for the second one. And for the third one, I'll be using a method called completing the square. The reason for using both of these methods is that you are supposed to understand both of them for A level. So if you're familiar with them, have a go at using them. If you're not familiar with them, then wait till I go through the examples and see if you can make sense of them. Anyway, pause the video, have a go at doing these 3 yourself. Okay, so the first question, z squared plus 16 equals 0. You can just use common sense. Move the 16 to the other side. Z squared equals minus 16, which leads to 2 imaginary solutions, z equals plus 4i and z equals minus 4i. The second question, I said I'd use the quadratic formula, so I will do. The quadratic formula is x equals minus b plus or minus the square root, and there's the b squared minus 4ac. And that's why it's so important. You're trying to find a square root of something. 3 possibilities when you find the square root. 2 solutions, 1 repeated solution, or you get a negative number, in which case we get complex solutions. Anyway, using the formula, putting the numbers in, 1 for A, 2 for B, and 5 for C, that is what you would get. Tidying up the bit in the square root, you get the root of minus 16. The root of minus 16 could be 4i or minus 4i. And then tidying that up by dividing through by 2, you get 2 complex solutions for this quadratic equation. Either z equals minus 1 plus 2i, or z equals minus 1 minus 2i. The third question, I said I'd use completing the square. It's a method some of you will have met before, but my guess is some of you haven't. Completing the square, the first thing we would do to make it easier using this method is just divide through by 3. So everything has been divided by 3. So this equation changes to z squared plus z plus a third. 0 divided by 3 is 0, so there's no problems there. The next thing you do is you set up a bracket so that these first 2 terms work. And it's got to be a bracket of something plus a number squared. Now, if I had z plus a half squared, that'll give me z squared. It'll give me a half z twice, so I'll get the z. The bracket is set up so that these 2 things work. And when you complete the square, that is what you always do. Now, there is one more thing I will get if I multiplied out those brackets. I would also get a half times a half. Half times a half is a quarter, and I don't want that quarter, so I immediately take it away. However, what I do want is a third, so I immediately add that on. After that, we just tidy up these fractions, move them over to the other side. After that, I've split this into 2, just to make it slightly clearer what's going on. So we've got 1/12 times by minus 1. On this side, we've got something squared. And on the next line, we're going to take the square root of both sides. The square root of the left-hand side is fine. You just lose the squared. The square root of the right-hand side has 2 parts to it. First of all, there's the square root of 1/12, which is 1 over 2 root 3. Then there's the square root of minus 1, which is I. The last thing that we need to do is move this plus a half over to the other side. And then we have the 2 solutions. Z equals minus a half plus root 3 over 6i, and z equals minus a half minus root 3 over 6i. You'll notice this fraction here has changed. That's because it's regarded as bad show to have the square root on the bottom of the fraction. So it's called rationalizing the denominator. Both the top and the bottom of the fraction have been multiplied by root 3 to give you that. If you have a calculator, I think it does that automatically for you anyway. Okay, that brings us to the end of section 1. And if you have the textbook, go to page 4 and have a go at exercise 1b. That is the end of the lesson. Thank you very much for watching, and cheerio.